Hi everyone. In this video we are going to discuss about theorem number 6 from the geometry of circles. There are two parts of this theorem. The first part says angle subtended in the major segment by a minor arc is an acute angle, and the second part says angle subtended in the minor segment by a major arc is an obtuse angle. So as you can see in the diagram, we have a circle there, and let's assume that CED, that is a minor arc. So the angle subtended by this minor arc in the major segment, that would be the angle F or angle CFD. We have to prove that the angle CFD is an acute angle, and also we have to prove that the angle CED is an obtuse angle, and also angle CED will be 180 degree minus angle CFD. So let's get started with the proof. In order to do the proof, I have to do a little more construction here. I'm going to join the point C and point D with the center. From the first theorem of angle properties, we know that the inscribed angle, in this case that is angle CFD, is half of the central angle, which is angle COD. So I have denoted that angle COD will be 2 times the inscribed angle, which is 2 times alpha. Now from the diagram, as you can see that the sum of the three angles there, angle AOC and the 2 alpha and angle BOD, their sum will be a straight angle which is 180 degree. All those three angles are below the diameter AB. So the sum of those three angles would actually form a straight angle, and I have denoted that as 180 degree here. And from here, can we then say that 2 times alpha will be equal to 180 degree minus the sum of the angle AOC and angle BOD? And since angle 2 times alpha is actually 180 degree minus some other angle, so definitely 2 times alpha is less than 180 degree. Now we have an inequality, and here if we divide both sides by a positive 2, then we will get alpha less than 90 degree. That means the angle CFD is actually less than 90 degree, which is an acute angle. Any angle less than 90 degree is called an acute angle. So we have been able to prove that angle CFD is an acute angle. So the first part of the theorem has been proved now. Let's focus on the second part. Now if you look at the quadrilateral CEDF, it is actually a cyclic quadrilateral. So what will be the sum of angle CFD and angle CED? Well, we have seen in a previous theorem that the sum of the opposite angles in a cyclic quadrilateral is equal to 180 degree. So in this case, angle E and angle F, or rather angle CED and angle CFD, their sum will be equal to 180 degree. And from here, can we say then angle CED will be equal to 180 degree minus angle CFD? And we can denote that as 180 degree minus alpha, because we are denoting angle CFD as alpha degree. We have already seen that alpha is less than 90 degree. And because alpha is less than 90 degree, can we say that alpha is then definitely 90 degree minus some positive angle theta? And next, I am going to use this value in place of alpha on the right hand side there. So here the angle CED can be denoted as 180 degree minus 90 degree minus theta. And if we remove the parenthesis, then this will become 180 degree minus 90 degree plus theta. So essentially that will be 90 degree plus theta. That means angle CED is greater than 90 degree because it is actually 90 degree plus some positive angle theta. So obviously angle CED is greater than 90 degree. And that was the second part of the theorem. So we have been able to prove the second part of the theorem as well. It is a very interesting property of circle that the inscribed angle of a minor arc is actually an acute angle, and the inscribed angle of a major arc is actually an obtuse angle. I hope everything made sense. Thank you for watching. See you in the next video.